So we're going to be looking at homologous series in organic chemistry. Homologous series. Okay. Before I define homologous series, I recall that I did see that organic compound is one aspect of chemistry that is studied extensively due to how complex and numerous they are. And the reason why they are numerous is because of the exceptional ability of carbon to show these properties we just earlier discussed. And because there are too many or numerous organic compounds, they are now further split or classified into families. And these families are called homologous series. You can want to pause the video and try to define homologous series. Whatever I say to viewers, homologous series is a series or family that are peculiar or common to organic compound that shows a regular structural pattern of which successive member differs from the next by a CH2 units or differs in relative molecular mass of 14.0 gram. Okay, we'll define it now. This is a series or families common to organic compounds that follows a regular structural pattern of which successive member differs from the next by a CH2 units. Okay. A series of families common to organic compound that follows a regular structural pattern of which successive member differs from the next by a CH2 unit or differs in molar mass of 14.0 gram. Okay, that is a homologous series, families common to organic compound that follows a regular structural pattern of which successive member differs from the next by CH2 units or differs in molar mass of 14. Remember what I say now, just say exactly what I just said now, that due to the numerous organic compound that they are now classified into families, and that these families are called homologous series. Without wasting time, I would like us to look at the characteristics of homologous series. Okay, let me do this. Okay, member differs from the next by CH2. That's one of the features of homologous series. 2. Members have the same chemical properties. Okay. Members of the series have the same chemical properties, but 3. Members show gradation. Members shows gradation in their physical properties. Members show gradation in their physical properties. That's where you see some members, lower members are gases, moderately small members are liquid, while higher members are gaseous. So these are differences, variations in physical properties, but members have the same chemical properties. You cannot just rule out the fact that members have the same physical properties. Does not exist. Members show some kind of differences in physical properties, but have the same chemical properties. And then number 4 features of homolog is that members have the same general molecular formula. Yes, members have the same general molecular formula, and then members have the same, or members belongs rather. Members have, let's put it this way, members have the same functional group. Members have the same functional group. And then number 6, members have the same method of preparation. That is, all members of the same homolog can be prepared by the same way. Please take note, these are the 6 common features or characteristics of homologous series. Please take them one after the other. Members differ from the next by CH2 units. Members have the same chemical properties. Members show gradation in their physical property. Members have the same general molecular formula. Members have the same functional group. And members have the same method of preparation. Okay, I'm going to be giving you examples of homologous series quickly. Main examples of homologous series, or those families of organic compound. Families of organic compound, number 1, we're going to be looking at alkanes. Alkanes. Okay. There are members of this alkane. Under this alkane, these are members. 1, we have methane. 2, we have ethane. 3, we have propane. 4, we have butane. Okay. Now, like you know, one of the features of a homologous series is that they all have the same general formula. The general formulas of alkane is CnH2n plus 2. Okay. This is the general formula of alkane. Okay. Now, where is N needed? N means number of carbon atom, whose value starts from 1. Value starts from 1, 2, 3, 4 till infinity. Okay. So in the case where the number of carbon is 1, so what I'll do now, anywhere I see 1 in this formula, anywhere I see N, I'll just substitute with 1. So this is C1, or just C. 1 here, okay, you can say C1 H2 bracket 1 plus 2. That's what I have here. Okay, which is going to give me C1. 1 times C, just C. 1 times 2 is what? H2 plus 2 is equals to CH4. This is the molecular formula of methane. And in methane, we take the number of carbon atoms there to be 2. So here we have C2 H2 bracket 2 plus 2, which is C2 H4 plus 2, which is C2 H6. And this is the molecular formula of ethane. The next one is C is going to be 3 now. So we have C3 H2 bracket 3 plus 2, which is C3 H6 plus 2, which is C3 H8, and this is propane. C4, that's the last one now. C4 H2 bracket 4 plus 2 is what? C4 H8 plus 2 is what? C4 H10. And this is what? Butane. Now, I can do this on and on and on till the 10 member. I can start from pentane, hexane, heptane, octane, nonane, and then decane. Can possibly I want to do the rest, but I want to stop at the fourth member. The fourth member series of alkane is butane. Is the 4 member. The member 4 of this family is butane. Then there's something I want to look at here. Look at it over here. I find out something that after methane, the next member of alkane is ethane. Like I said earlier, when I defined the homologous series, so that this is a family that is common to this organic compound that follows a regular structural pattern. If there's a regular progression in the formula here, that the next member will differ from the next by CH2. If you look at the molecular formula of methane, where we have CH4, and then ethane, where we have C2H6. The difference in the molecular formula between these two here, the next member of this is this. So the difference in the molecular formula of the two members here is CH2. That's the homologous series. Or difference in the molecular mass, relative molecular mass. The atomic mass of carbon is 16. Sorry, it's 12. It's 12. Atomic mass of hydrogen is 1. And there are 4 atoms of hydrogen in that methane. So that gives me atomic mass of 1 times 4 plus 12. That means the relative molecular mass of methane is 16. The relative molecular mass of methane is 16. And then the relative molecular mass of ethane, that's the next after methane, is 12 times 2. That's atomic mass of carbon is 12. And there are 2 atoms of carbon in that formula. 12 times 2 will give you 24. 24 plus 6, I guess, gives you 30. 30, I guess. 30. And then do the same thing to the next one here. 12 times 3 plus 8, I think that gives you 44. 44. And then do the same thing to the last one in butane. 12 times 4 plus 10, I think that gives you 48 plus 10, I think that gives you 58. Okay. Now, the next member after methane is ethane. So what is the difference in the molecular mass? The difference in the molecular mass of methane to ethane is just 14. The difference in the relative molecular mass of ethane and propane is also 14. And the difference in the molecular mass of propane to butane is also 14. So that means that, look at how it is now. Successive member of methane is ethane. Successive member who is succeeding ethane is propane. Who succeeded propane is butane. You can do this on and on and on till the 10th member, as the case may be. And with that, you can be able to derive the general molecular formula. And this is on the family of alkane. Okay, I would like us to look at this problem. Okay, and see how to tackle it. A question may arise. Let me put it as a question. Okay, you can pause the video and answer it. A normal alkane has the molar mass of 58.0 gram. Then you're asked to deduce question A its molecular formula. B, its structural formula. And D, its impact name. Okay, you want to pause the video and answer the question. Okay, what do we do? We'll solve the problem quickly. The general molecular formula of normal alkane, general formula, please you know this, general formula is CnH2n plus 2. This is for alkanes. Once you see this formula, this is general formula of alkane. From this formula, you can be able to generate all the members of a series from 1 to 100, or as the case may be. Okay, let this be equals to the molar mass of the alkane given, which is 58. And they will substitute. You will be given that the atomic mass of carbon is 12. N plus atomic mass of H is 1. 1 times 2 is 2. N plus 2 equals to 58. Okay, 0.0 if you like. This will give me what? 14N plus 2 equals to 58.0. Therefore, 14N is equals to, making it a solid formula, will be equals to 58.0. This is going over here become minus 2. Then 14N is 56.0. Okay, so what do we do at this point? We divide both by 14, both sides by 14. So have here 14, here 14. Okay, here. So N here is equals to 4. Okay, so what do you do? To answer the A part of the question, I want to answer A now. A part now say its molecular formula, Mn. How do I get the molecular formula? Okay, since the number of N is 4 here, the value of N is 4, so in this general formula, anywhere I see N, I just substitute 4. That's what I just do. See here, instead of N, I just have to be 4. Here will be 4 times 2, 8. 8 plus 2 is what? 10. That's all. That is C4H10. Now let's solve the B part of it, structural formula. What I'll just do, since it's a normal alkane, all normal alkane must be straight chain. So I'll arrange this number of carbon atoms, 4 of them, in a straight chain. 1, 2, 3, 4. And I place bond to every carbon. Make sure that every carbon here will have to be 4 bonds. 4 bonds. 4 bonds. Give every carbon here 4 bonds. And then arrange your 10 atoms of hydrogen in it. So here we start with here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That is the structural formula of the compound. Give it a packed name. Since this is a hydrocarbon with 4 carbon atoms, a hydrocarbon with 4 carbon atoms is both. So since the carbon, all single bond, so the suffix or the ending will be A. So the IUPAC name, IUPAC, is both T. That is on that question. That is on families of alkane. Okay, you may want to pause the video and see if you can try out with other related molecular mass and see what formula of alkane is deduced from that. Okay, we'll quickly look at other families of organic compound. That will be alkanes. That's number 2. Alkenes. General formula is CnH2n. As against plus 2 in alkane, there is a reduction of 2 atoms of hydrogen. And that's why we shown that plus 2. So it's CnH2n. But you should know that basically that n, value of n is start from 2, 3, 4 until infinity. Please be aware of this. There is no n equals to 1 in or alkene. Okay. Then, since n is equals to 2 now, let's start from n equals to 2. If n is equals to 2, so anywhere I see this n needs to be 2. So therefore here is C2, H2 to here is going to be 4. So this is ethane. There is no methane here. So ethane is the first member. Ethane is the first member alkene. Not like methane here. Methane does not exist. Okay. Then if n is equals to 3, so what I will do anyway, I'll see this n here to be 3 now. C3 H what? H6. And this is going to be my what? Propene. Propene will be the second member here. Second member. member 2. And then the last is we're going to be what? N is equals to 4, which is C4H what? 8. And this is going to be my what? Put in is member 3 or third member. Okay. That's what I have. So in this case now, these are homolog, member of the same family. Members of the same family. If you look at these two now, successive member of 18 is propane. So difference in its formula. Difference in the formula of these two, the difference in the molecular formula is CH2. The difference in the molecular formula between this and this is also CH2. You can also relate it with the relative molecular mass, which is going to also be 14 in difference. The major difference that exists between the molecular formula, molar mass of this member of the same family. And quickly we'll move on to the next family, which is alkyne. General formula is CnH2n minus 2. CnH2n minus 2. This particular members here, members of this family differs from that of alkane by short 4 of hydrogen atom. Differ from alkane by short 2. So that's why we have a minus 2 here as against plus 2 and plus 0 and then now minus 2 now. Okay, so but value of N here also just like alkane, because this is where these hydrocarbons appears to have multiple bonds. So because of that multiple bonds, the value of N does not start from 1 but begins from 2, 3, 4 and so on and so forth. Okay, so in this case now, if N is equals to 2, we're going to have C2H, okay, 2 times 2 is 4, 4 minus 2, so here will be what? 2. So this is the molecular formula of the first member, which is ethyne. This is ethyne. Okay, so but if N is 3, is have C3H4, and this is propane. Okay, and then if N is equals to 4, we have C4H6, and this is propane. Okay, so this is first member, second member, and then third member of alkyne. And then quickly, we look at the another member, another family, which is the alkanols. 4 alkanols. Alkanols CnH2n plus 1 OH. Okay, but you must know something here. Okay, where CnH2n plus 1 is the alkyl, called R, and then OH is the functional group. Okay, but value of N begins from 1, 2, 3, 4 to infinity. Okay, and then if N is 1, so we have here C1, 1 times 2 plus 1, H3, OH. Okay, this is the first member of the alkanol, which is methyl. Since that R is there, this is methyl. This is methyl alcohol, or I can simply call it methanol. It's just changing, removing the E ending of the alkane with OL. Okay, and then if N is equal to 2, where we have N, we have 2, where we have N, we have 2. So here will be 2 times 2, 4, 4 plus 1, 5. And then OH. What name is given to this alcohol? Please, you can pause the video and try that. So this is going to be what? Ethyl. That's the R there. R there is ethyl. And this is ethyl alcohol. Or I can simply call it ethanol. Okay, so this is on that family. But a lot of this will be discussed when I'll be explaining in this video. I'll be explaining functional group. I think I have to exhaust many families. I think I'll be giving you up to 11 to 12 families of organic compound. apart from just what I just did there under homologous series. Just take note, the homologous series are members of a serious member of series that have a particular progression in their geometric strength, of which members are going to differ in some kind of peculiarity depending on the situations available in that family. So this is homologous series, and the reason why in organic chemistry today homologous series is very, very important is because of the vast majority of organic compounds that exist, and the only way to understand organic chemistry is by classifying them, trying to break their ranks, and to be able to group them into smaller group, okay, subgroup, and this subgroup is homologous. So under these families, alkanes, there are so many members there that will behave differently to other members. Like there's the alkanes, and alkanes are so different in so many ways. One of the difference is that one has multiple bonds, the one has just single bond. In their properties, they are not the same. In their method of preparation, they are not the same. To show you that these are different families that behave differently. So this is on that. Quickly, we're going to be looking at the features of organic compound. Before I go back to homologous series again, but this time functional group. So let's look at features of organic